All right, welcome everybody to today's webinar. This is Fred Schenkelberg, and with Accendo Reliability. First off, this was scheduled originally for last month, and due to pretty crazy weather that we were having in the local area, and lack of all kinds of different services, and very, very poor connection through my cell phone, didn't want to risk putting on a program that would probably get dropped about 5 or 6 times. And so for those that didn't see the notices that we were canceling it and postponing it for a month, I apologize for the confusion when you tried to log in. I didn't really have a good way to get a message to you. So, but we're back today. It's bright and sunny here. Things seem to be green across the board. So I'm going to go ahead and get started with today's webinar, and hopefully everything works like it should. Let's see, there we go. Now, the status of reliability education is really I could take many different angles to doing this, and part of it is that one of the things I get through the website and through the analytics, looking at what articles people are typically taking a look at, what articles people are landing on when they visit the site, when they're either going directly to the site or searching for something, are usually basic stuff. Definitions, how-tos, 8 steps to create a control chart, things like that are amazingly popular. And I understand why. I know I was hitting the library and the books and everything else I could find as resources back when I was learning a lot of this stuff, and I still do. If I have a question, I get online real quick and look it up, or oftentimes I know where it is on the Accendo site, so I go find it. And if it's not there, then I make a note that I should probably write about it or ask somebody to write about it. But we never end our quest for refreshing our memory of, well, how exactly do I do a paired comparison hypothesis test, for example? I don't know that by heart. I don't do it every day, but I do know where to look it up and have the basics of the sets of tools we use on a regular basis is a pretty solid foundation for what we all need to know and to refresh ourselves on and stay current on. And so there's lots and lots of basics of places we can go to understand and learn about the basics. And we'll talk about a whole range of different ways people go about doing this. And then, of course, there's advanced stuff. There's higher order statistics, higher order techniques and modeling and working with corporate risk management type stuff or enterprise risk management. Oh, slew of different advanced topics that we get into and we can get touched into. And again, there's a wide range of opportunity, not as many as for the basics, but there's a good range of options available to us, both free and paid options that allow us to master both the basics and the advanced topics. So there's plenty of ways we can get into all of these various tools and topics. And then the last part of this is that, as I alluded to when mentioning the basic skills that we all need to have available to us and regularly use or refresh our memory on and use again, is that we do that all the time. We are constantly learning. We've got a new material that shows up in our design team, and we have to learn about, well, what are the relevant failure mechanisms for it? What kinds of stresses apply to that? I got an email the other day saying, hey, I've been doing accelerated testing where we test to failure with a range of samples and have pretty decent models because we know the failure mechanisms. But I just moved to a new company, and the number of things that they're interested in really aren't made to be tested to failure, but they have degradation type patterns. And so provided a short list of places they could go to learn about degradation data analysis and accelerated testing, which is similar to accelerated testing, but slightly different, a little bit different take on the type of math you would do for it and the type of analysis you do. But it doesn't seem like we ever run out of things to learn. And it's that notion that once we get out of school, we're not done. And I think that's really true for reliability engineering. We get to work with all the different fields in the design or in the factories, from manufacturing to supply chain to procurement and finance and everybody else, and sometimes even marketing if you're lucky enough. But there's so many different things that all of those different fields that we need to be at least familiar with in order to be conversant and effective in working with all these different teams and all the people that we need to work with. So the process of reliability engineering education or learning is not going to end. And part of the goal of an Accendo is to provide a lot of what you need when you need it. And also we spend a lot of time promoting different books and courses and all kinds of other materials that are part and parcel to helping you continue your education in the field. All right, so if you could hit the chat window with what's your favorite way to learn. A couple of weeks ago, almost a month ago, I was running a survey that was listed 10 different ways people could learn. And it went from courses to mentors to trade magazines to technical papers, conferences, stuff like that. And courses and conferences were the two top picks. But one of the comments was really insightful. It said, sometimes a conference is the right thing to do because I get exposed to new things. I get caught up with people in the field that I know and my friends and colleagues. But sometimes I just reach for a book because I need to look up something, and that book has the algorithm or the method there for me to use it. And sometimes I need to go talk to a mentor. I need to talk to a colleague or somebody that's advanced in the particular area I'm interested in and pick their brain. And he said, and the comment was, of all the different methods, they all have their uses. They all have their place in our daily and ongoing education in the reliability field. And so it's hard to prioritize which one is which because it's so situational. And I thought that was insightful. So let's see if I've got any comments there. No, okay. All right. So why do we learn? I've alluded to this a little bit already, but why do we spend time learning reliability engineering? Well, one of them is just basic skills. And it starts way back, even before kindergarten, actually. But as we become more proficient in the engineering fields and we learn the statistics and the algorithms and the modeling and the material science and all the other things that go into what we do, at one level, it allows us to have a language, right? An ability to talk about identifying problems and solving them. And it gives us the tools and techniques that allow us to make comparisons or set priorities or evaluate how we can create a successful product or improve the uptime of our production facility. But it also allows us to communicate. And part of our skill set is, and I've been a strong advocate of this for years and years and years, is that just because you can do a Weibull analysis, if you can't communicate it well, you lose the edge that you could have. Much of what we do in reliability is influencing people, and creating a beautiful Weibull plot is part of that. And I'm using that just as one example of the many things that kinds of things we do and put together and propose. But we also have to be able to communicate well, and that's in conversations and presentations, in writing and so on. And our skill set then doesn't stop. And many of you have probably heard that one of the best ways to learn something is to teach. And I know that's true personally. You really get to master a topic when trying to explain it to somebody else, and they're asking questions about how this fits, or how's this work, or what's the next step, and things like that, or where'd this come from. It really helps you cement what you've known, what you know, and that combines your skill sets, all of the calculus and statistics and everything else that we pick up along the way, with your ability to communicate, to influence, to inform. And so the reason we learn is to be effective at what we do, right? To add value to our customers and organizations and ourselves. And it allows us to be, one, conversant, but two, we actually can contribute. And part of it is learn a little bit and then move on and share it, and move on and share it and learn some more, and run into some more questions and go learn that. I once asked, what made a person an expert? And my boss said, well, it's somebody that's about 2 weeks ahead of you, and they can answer questions you're not ready to answer yet, kind of thing. And I found that to be true. Is if you did 2 weeks of serious study of some particular topic that others just haven't taken the time to do, they don't have to. They can come to you as the expert and do this. So be careful what you study real well, because you might end up becoming known as the expert in that, and then get targeted for those kinds of topics and questions. Now, the other thing we do of why we're learning is it gives us opportunities. I mean, this one's obvious. Look at a job resume, right? We're listing, here's the things that we know about, here's where we went to school and the topics we studied, here's the kinds of problems we solved in the past. And that may well open up doors for us for another opportunity, for another position, for a different company. And like that email I mentioned earlier is where they were pretty well versed with the pretty basic, 3 stress level type of accelerated testing. They had the opportunity to build on that and in a new organization by extending their knowledge into degradation, accelerated degradation testing. And that just broadens their resume. They have now 2 good skills instead of just 1. And a lot of what we do in reliability, and I was just talking to Philip Sage yesterday about this, is that reliability spans way more than just doing predictions and Weibull analysis and taking a look at root cause analysis and so on. We very likely can be engaged with the finance team, with mechanical engineering, with the software teams, with the plant operations, with manufacturing engineers, with suppliers, with procurement teams. The span of areas that we are effective in oftentimes is great opportunities to add value within the organization, but it also allows us to continue to learn and to continue to influence in a more effective and greater span of an area. Now, one of the things that I found is that even if you're just pursuing a hobby, right? And I remember I've been a woodworker and building stuff around the house in my shop for years and years and years. One of my very first consulting projects was with a problem where this extruded polymer on the side of a hot tub was detaching after a good number, a couple of months of thermal cycling in the sun. And they were trying to bolt these things on or staple them on and all kinds of different ways to attach them. But my reliability engineering knowledge was enhanced because of this woodworking hobby that had various attachment techniques for dealing with the expansion and contraction of wood, which it very naturally does with changes in humidity or temperature. And so using a slotted opening for the bolt so that the bolt could maintain connection, but it still allows the polymer to expand and contract and extend. It changed its length by almost a half an inch and over the throw of this particular extruded part, solve their problem. But it wasn't any particular reliability engineering knowledge. It was, I did some dabbling in making tabletops that use that kind of attachment method, and it solved the problem for him. So I think our ability to continue to explore and understand and read and try different topics and different areas of interest, it only comes back to help us be more effective at what we do. And I found that is that one example in a very early project for me, which made me double down on getting a new table saw for the home shop. But I don't know if that was probably not the most effective argument, but I used it anyway, and it got a new table saw. And the other thing is, the final part is that the skill sets we have and how well we can do what we do, it leads to us being, having a job that they continue to pay us to do, and leads us to, paying off the mortgage and buying a new car, or, quality of life and all those kinds of things. But for some people, money isn't the only thing. It's also that we have this satisfaction. We can actually help people solve problems. We can be presented with opportunities, or even better is we can identify opportunities because of the set of skills and what we've seen and learned, and how we look at a problem changes because of what we learn. And it allows us then to identify opportunities to make improvements, to make things work better or smoother or easier. And I find those kinds of rewards much more valuable than just the getting paid for what I do. Not that I'm going to complain about it, because it sure helps when you go to the grocery store if you have some money. But the idea is that the engineering work we do often has a pretty amazing impact across our fields that we work in and the different industries we work in. And so we learn to underscore our ability to gain skills and to communicate well and to influence others. We also do it because it has real tangible value for us, for our organization, our customers, and our society. All right, so here's a little change of topic to you, and hopefully somebody mentions the Sendo. And Andre mentions the RAMS tutorial sessions have been very popular. And I agree. Usually they pretty much fill the room for for those sessions. And it's a great way to spend a couple hours on a particular topic and have the person right there you can go ask. And I find that after most of the times I've done that, is you spend another half hour in the room answering questions, which is always fun. I enjoy that. And Stefan mentions online resources, YouTube. I was able to fix my chainsaw. The trigger wasn't working correctly. And a couple of YouTube videos on that particular model, was like, okay, I can do this, and was able to avoid having to go to a repair shop for what ended up being a very simple fix. But there's YouTube, I think it's stating it's like the second largest search engine. And the number of hours of video that's posted on it per day is staggering. But there's lots and lots of things to go there. Sue's saying mentors, and don't underestimate the value of having a couple of folks you could knock on the door or send them a note and saying, hey, I got a question. And somebody you trust that is going to steer you well, or has got experience that they're willing to share with you. It's a great way to learn. David's mentioned the Risk and Reliability Division. I know they do courses. They have a regular newsletter. They encourage people to write papers for like RAMS and their own conference. And I was the chair of that years ago, and their mission is to help people learn. That's really what they do, is learning about risk and reliability. And so, and they have the webinar program, which is still going. It's very popular. So that's a great way to pick up a whole bunch of information and knowledge. All right. nobody mentions, when I ask this question, nobody mentions going to a Zoom meeting, a meeting for work where and sometimes we learn useful and informative stuff in a regular staff meeting. But it's generally not where we go to go learn something, but you can ask questions there. There's no doubt about that. All right, now let's talk about where we can go. Here's kind of my take on all these different things we can do. Now, first, let's just talk about some of the free options. The first one is you can do it on your own. There's nothing saying you can't go invent a methodology or reinvent something that somebody else did, especially if you know it's already been done. You have a pretty good head start over the person that created, say, a hypothesis test algorithm for the first time. It takes a bit more work. And knowing that it exists out there, there's plenty of other options available for you. But the idea is that some of our best learning is done on your own. Discover it yourself. I don't know how many times I've been in the lab with a new piece of material or type of component and just played with it. Just how does this thing work? And more importantly, how does it not work? And yeah, I could do a bunch of research. I could study this, that, or the other thing, but I found it more fun to go blow stuff up in the lab, so to speak. But it's a great way to learn. And sometimes it's our only option. The literature that's available online is not going to have your particular product's design. And I've used the story many times. As I had was working on an inkjet printer, and the design team wanted to attach a circuit board vertically with only an attachment at its base. So it was, I don't know, 4 or 5 inches, 6 inches long, a couple inches wide, but standing vertically with an edge connector just supporting the base of it. And the mechanical engineer didn't want to attach it anywhere else because of the amount of tolerancing and everything else. And circuit boards are not very precise in their thickness and all these other things. And he knew he didn't want to bend the circuit board or put it under strain. But you can imagine that this would look a lot like a diving board standing straight in this printer, which had a big chunk of mass that was going back and forth across the page as it printed. And so I didn't know for sure. I didn't do the CAD modeling or anything else to look at this. We just we took the skins off, the outside of it off, put it in the lab and started printing and just watched that circuit board. And we had a high-speed camera. So we put that on it so we could slow it down and see what kind of vibration it would do, what kind of response to this motion it would do. And it quit running after a few seconds. The high-speed camera luckily caught the component flying off the circuit board. It didn't take very many cycles for this thing, and it was moving about a 1/2 inch, maybe 3/4 of an inch at the top, back and forth. And it was just a single oscillation, single point of oscillation, but it was enough to curve the board to really quickly weaken the solder joints in this one particular component. Flew off, and that stopped the printer. It was one of those cases where having that video was all I needed. Maybe I should have put it on YouTube. Probably would have got frowned on for doing something like that. But the mechanical engineer the next day had like 2 or 3 different options to attach and stabilize the circuit board in the design, which then went on and did just fine in the field. But that was just exploring it, just seeing how will this move, how will this change? And then we could have used modeling, we could have used a variety of different techniques. But sometimes running your own set of experiments is a wonderful way to learn. But there's also all of these other vehicles out there, from books and magazines to websites and podcasts, webinars like this one. But as I mentioned earlier, is you can do speaking and teaching, say in an evening meeting for IEEE or ASQ or SMRP, present at a conference. If your company's paying for it, it's free to you, it takes some time. but it's the local sessions that in many parts of the country and around the world are always looking for people to present. And so if you can put together a couple of topics and offer them to these different organizations, you could probably get on the calendar. And I know that now many of these organizations are using Zoom or something like it. So they don't even have to travel to their location to do their presentation. And then there's a whole pile of courses that are available that are free. I'm thinking of EDX as my prime example, but there's plenty of these university level courses and seminars and workshops and through Coursera or through EDX or MITx or Stanford X, that for whatever reason, X became the symbol of that it's an online course. Many of them are free. Now you can pay a fee to get a certificate that you took the course or get your homework graded, things like that. You don't have to. There's all kinds of courses available. Many organizations connect into what used to be lynda.com. I think, well, I know LinkedIn bought them. So it's a learning platform for them for online courses. And some of those are free, some are paid. And then mentors and having colleagues and friends that you can tap to ask questions and bounce ideas off of and things like that. Those are all free. And you can create a whole career out of, or learning plan out of just all these free things. And I've heard that from a number of people, especially around the webinars. I heard from one group that says, each month we get together in the conference room and listen to the webinar and discuss the topics and so on. And it's become a regular piece of our ongoing learning is the webinar programs. And so it's a way to be exposed to new ideas, to refresh your memory or knowledge of a particular topic and so on. So it's lots and lots of options that are free. Now, low cost is build your own library. One of the surveys I did recently, and Andre, and I see you on the attendee list today. Andre Kleiner is the co-author of the 5th edition of the Practical Reliability Engineering book, which is still very, very popular in our field. It's close to the top selling one, according to the day I looked at the Amazon statistics. But it's in its 5th edition, along with Pat O'Connor doing the first 4. It's still a go-to book for me and for many of our colleagues. It's on plenty of shelves. And so thanks, Andre, for making that available. And I know that he's also available to answer questions if they come up from that, if you get a hold of him. And through LinkedIn is probably the easiest way. But there's also, you can get a subscription to the learning sites that have a series of courses, or you could subscribe to a magazine or a journal like IEEE or ASQ or SMRP for the memberships or subscriptions within those memberships. And there's plenty of courses and seminars that are modest cost. And I think of Udemy, where oftentimes the course might be priced at $79, but because of the way Udemy works, it might be available for $10 for a particular period of time. So there's a wealth. I don't know that there's as many low-cost courses and seminars as there are free ones. But sometimes it does cost time, and it's a lot of effort to put a course together. So some people are looking for some compensation on it. There's also some that are much more expensive, but also much more specialized in many cases. Right. Yeah, and Carl mentions that the internet's opened up so many opportunities for education. And I'm thinking of the EDX program in particular, is that you can sit in on a class from universities from around the world and participate in discussions on those and so on, and they're free. It's just mind-boggling to me as how many different available options we have that are low cost, and many of them are free for all kinds of subjects. Now, the EDX, I have yet to find a reliability engineering course on the university level that's available. Now, there may well be, but I haven't run into it yet. So maybe that's an opportunity for, say, Andre, maybe you could put together some courses that is in a massive open online course. That would be fun. But there's, I know there's great statistics courses. There's courses on how to present well, how to write well, all kinds of different topics that would, in finance and in risk management and so on, that are related to what we do. There's a handful in quality, not as many as I would have expected at the university level, but there's some of those out there. When you get into courses and seminars, then there's a bit more in the reliability world available, and Zendo is certainly a part of that. But there's plenty of options out there. With a quick search, you can find plenty of ways to learn what you need to know. Now, of course, there's another option, which is the ones that are expensive, and you can take tailored courses. You can bring in an instructor and get a custom curriculum built just for your team. Conferences, they cost on the order of $1,000 to register, plus travel, plus time away from your office, things like that. You can go back to college, go get a degree or two in these various areas. I know University of Maryland, University of Tennessee, and dozens of others around the world offer various degree programs in reliability or very related fields. And if you really want to get good at what you're doing, get a coach. There was that years ago, there was a notion if you spent 10,000 hours, you could master a subject or become an expert. And it was often cited out of context. It's not just swim for 10,000 hours and you're an Olympic caliber swimmer. No, if you have a good coach that gives you deliberate feedback, very specific, actionable feedback as you continue to improve, the coach is giving you just the next step so that you can work on that and master that finer point of that particular topic. Well, the same goes for reliability. You can hire a coach, somebody that has a bit more experience, but also is good at helping you go step by step to master the particular topic, whether it's doing presentations or doing Weibull plots and doing data analysis. But getting meaningful feedback is why people go to courses and degree programs and hire consultants or get coaches, is because it allows them to get very specific feedback to help them improve, to see the problem in a different way, to understand what works and what doesn't work, and to learn in a very tailored, very specific way that allows them to spend those 10,000 hours very effectively to get really good at what they're doing. And yes, they're a bit more expensive because it's very intensive, but it's also amazingly effective. All right. So Andre, I mentioned your book. That's one of my go-to books. The other one is by Wayne Nelson, where it's accelerated testing. I've been using that since the very first time I got involved with anything related to reliability. And I think I'm on my second or third copy of it, because after a while, the bindings start to fail. I should probably buy another copy before the price of these things go way up. But there's lots of books available out there, and it's probably something I need to update. I did the bestseller list thing through Amazon. Went through and searched for reliability engineering and in books, and then opened, I don't know, probably 200 or 300 different titles that Amazon identified with reliability engineering, and then looked at their sales ranking. And I know that it changes, if not on an hourly basis, but on a daily basis, so that where most of our books are listed in the top 10 to 20 list, is in the, say, 50,000 rank up to 250 to 300,000 rank, somewhere in there. And I think if one book sells in a month, then you probably shift your ranking quite a bit. So unfortunately, our reliability engineering related books are not in the New York Times bestseller list. But maybe someday that'll happen. People will finally understand that it's useful to read about this reliability. Let's see. There's a bunch of ways we can learn. I mean, there's all these different vectors of books and magazines and conferences and mentors and so on, but there's lots of different ways we can learn too. So one of them is just self-study. And here I recommend reading. Read widely. Read anything you can get hold of. Trade magazines, technical journals, stuff related to your industry, the trade journals in your industry, or magazines and newsletters in your industry. Subscribe to different newsletters or blogs that come at the topic in a variety of different ways. You never really know when that particular bit of information brings a new insight when you're faced with a problem at some later point in time. And so you don't have to wait till you have a problem to go find answers. Which is a good idea. You can also spend some amount of time, and I ran into a few people that allocate, 2 to 4 hours every week to deliberately block their calendar to read, to research, to attend a course or view an online recording of something, possibly even go to YouTube and look for topics that are related to what you're interested in, and just learn on your own. And you can do it in a structured way. Some people that works great for. I'm going to learn all about, say, accelerated degradation testing, and I'm going to go find the right resources and work through it. And others will wait until they have a problem or a question or a curiosity, and they then pursue it and go look for it in a more random type of way. But the best thing by far is go give it a try. And what I often recommend is that, especially when you're working with a software package and doing some analysis, find a copy of a blog post or a book or a journal article or something that has that similar, an example problem with the math that this package is supposed to do. And can you replicate the answers? And if it's not obvious or easy to do, well, is it the reference you're using or is it the software? And then you probably are going to learn something either way, which one works with. Yeah, and David, I agree. It's self-study is when it's motivated by the desire just to learn something, to explore the world around us. It can be just one, fulfilling, but also very effective. And myself, I'm not all that terribly organized, so I rarely said, "Oh, I want to learn this topic this year." But when I get started on something, I usually go pretty deep and try to fully understand it. But sometimes it's just reading years ago, I used to, or the library for the organization I worked at would send me the table of contents for a whole range of journals that were in areas that I was interested in. And I would highlight the titles of the articles that caught my attention. And then in my commute, I was on a train for about an hour each way every day, and I would read those articles. They would send me the photocopies of those articles from those journals. So I get a packet of like an inch thick of these journal articles every couple of weeks. And over the next couple of weeks on the train, I would read through them. Now, some of them were boring as all get out, and some of them are way over my head. I remember reading like 3 or 4 different articles that mentioned Monte Carlo studies. And I'm like, what in the world is that? And went back to the librarians and said, what is Monte Carlo simulation or study? And so they sent me some papers that described it. But it was just being curious, what is this? I don't have a foundation of what this is. And so I was able to explore and pick up another technique that ends up being pretty powerful when used well. So another method of learning is guided. And that's where workshops and courses and seminars, those kinds of things come into play. University programs, like if you're going for a degree program, you probably have an advisor matching what you're interested in with what they offer, and gives you both a broad sense of the field, but you may end up with a specialty in that. And I know in my statistics grad school, they made sure that you had a good foundation, a bunch of required courses and the range of topics, some less desirable for what I was interested in, but still paid off, versus the areas especially that I was interested in, more very practical stuff for dealing with data analysis in a factory. And so there was a bit of flexibility, but it was guided. The counselors and advisors helped you to pick things that would, one, meet the requirements for graduation, but two, broaden your ability to solve problems and to use the information you have. And these are, again, a wide range of things. I should have added mentor to this one. Some mentors, some mentorship programs and relationships are a bit more deliberate. I've run into one of those early in my career. She would leave me with a question oftentimes, and she was very gifted at going, well, have you ever thought about XYZ topic? Maybe you could pick up a paper on that, or I have a reference on it. You should take a look at it. And over time, I realized that she was very deliberate about increasing my knowledge along the areas that I needed to be good at for what I was doing, but also what would help me take small steps. And so it never felt forced. I wasn't under any deadlines or anything like that, but I sure enjoyed it because the stuff she would recommend was, well, this is interesting. This is useful. I could do this. I need to know how to do this, those kinds of things. And so finding a coach or a mentor that can help direct you for a line of reading or courses or seminars or whatever is a great way to be helped as you learn. And now you can go out and seek people that deliberately do this for you, or you could build that through like a mentorship program. It's another way to go about doing it. But I found this one, the guided methods. I like workshops way better than seminars, because oftentimes workshop implies that we're going to work through a case study, or we're going to do examples and get to practice it and to get advice, somebody over your shoulder saying, that's a way to look at it. How about this? Well, what does that mean to you? Well, let's think of it in a different way. Those kinds of comments and feedback is much different than just a straight off lecture like this webinar. So having that interaction is a step better than just a straight lecture. And then another whole way to look at learning, when I was looking at different options for this, is you can be reactive or proactive. And I don't know that there's a right way or wrong way to this, but I suspect it's a balance of the two. Is that if we're only reactive, we're going to be a day late and $1 short. And yeah, it can be exciting. And we are actively trying to learn what we need to solve yesterday's problem. I think a touch of proactivity allows us to have a different demeanor about what we're learning. And I think it registers in our memory in a different way. If you're only reactive, I have a test on Friday, so I learned just what I need to do to pass that test. And I know this from my college days, is that people that did that then really didn't retain much of anything. They were looking at the next test and prepping for that, and then forgetting what they just had spent time learning and focusing on the next urgent problem in front of them or challenge in front of them. Whereas somebody was proactive, they're saying, I need to know this, this, and this, and I suspect I'm going to have problems or questions in the future for that, but it's learning more for the sake of learning it. And that's harder to justify in some cases. I think some people are more prone to do it than others. But the idea is that I firmly believe that the more we learn, the more that we can learn. And that the ability for us to build on what we know, it only works if we retain what we've learned. And one of the greatest ways to do that is to use it, to pull out the information that we have and use it to apply novel solutions to problems or to frame problems in a way that we can attack. I use that story of the woodworking fittings to deal with expansion with this polymer extruded siding for a hot tub. Is the learning in one field often helps us solve problems in other fields. Even though I've learned some very advanced mathematics while in school, I've rarely used it directly. Yet I firmly believe it allows me to see potential solutions to problems in ways that if I hadn't had the advanced calculus stuff, I wouldn't have really grasped how to approach the problem. Now, I haven't actually solved an integral in a long, long time by hand. We got great software packages to do it. But it's one of those things where knowing that knowing those basic algorithms and basic approaches to solving problems allows me to approach problems in a different way. Now, I'm not real sure if I'm being clear on that, but our proactive ability to push what we know, to struggle to learn something that is not trivial or easy to master, allows us to expand our ability to solve problems, not just with that particular technique, but with the way we think about how problems can be framed and set up and identified. So hopefully that makes sense. But I strongly suggest being proactive as much as you can. Set up a learning plan so that you are staying ahead of what you need to know. Yeah, maybe half of what you pick up you won't use this year, but you never know which half is going to be the useful stuff. So it's 10 webinars like this audience does. You never really know what you're going to get into. A step further is to get on the monthly webinar listing that we do at Accendo, which we look at, I think, close to 40 different organizations that offer webinars in the reliability and related fields. And so you can pick topics that catch your interest and probably have more hours of webinars than you have time to attend. But you don't have to pick just one program. You can pick the topics and areas of interest that capture your attention. That might be an interesting way to expand your webinar repertoire. Not that I want you to stop attending this one, but I dare say. So basically, do you have a learning plan is kind of the question to leave you with. It can be very informal and kind of random. It could be, I'm going to set aside so much time per month or week to do this, or I could be very detailed and have specific objectives and certifications or degrees or mastery of particular topics to some criteria. Or maybe you have specific problems that you need to go solve, as that email I mentioned at the top, looking at how do I learn about accelerated degradation testing and how is it different than the other kinds of accelerated testing. And starting with a good question is often a great way to start a learning plan, but I'd say give it some flexibility. So part of that learning plan should be proactively pursuing things you don't know that you need right away, but are in the field in areas of interest. So that's one way to go about doing it. So I think I got one more comment here. And so this is the part for you for comments and questions. I know it. One thing I ran into just yesterday was a paper, or it was a presentation coming up about using not artificial intelligence, using virtual reality headsets to learn about transportation methods and the different challenges the transportations feel. So you can imagine putting on a headset and then you're riding the train, or you're, flying through the air, or doing whatever the different transportation modes, but you can become pretty immersed in it without having to go to all these different sites to travel all these different methods. And some of it could be quite exotic and not even invented yet. But it's a way people are trying to take the newest technology and build learning engagement out of it. And some people are getting pretty creative at it. I think there's a bunch of, I know Facebook's really pushing the virtual reality, what do they call it? The metaverse, I think is the name of it. I don't really know. As a way to attend lectures, for example, things like that, where it's not quite in person, but it's a bit different than a Zoom call, for example. Let's see. Got a question here from Maximilian about a learning plan for someone who's completely new to reliability. That's a good question. Well, one, get Andre's book, The Practical Reliability Engineering, because it's kind of a handbook. It covers FMEAs and basic modeling, like series and parallel models, and a handful of others, but also just the basic concepts of what is reliability and reliability engineering. Where does it fit into organizations, those kinds of things, and what kinds of things can we do? But it does a good job of exploring and introducing a pretty good range of topics, of different methodologies that are common across all kinds of industries related to reliability. That would be a first start. But it's, and Maximilian, I know that you attend these webinars quite often, so that I recommend that also. I'm glad you're here. But then it's basically understanding in the organization or the area of your particular interest. If you wanted to become really good at accelerated testing, for example, it's a different course of study than if you wanted to be really good at simulation modeling, for example, material properties or heat transfers, both of which we could do. And it's related to many reliability types of fields of interest, or root cause analysis, or where's, the warranty policies, which is more of a finance and area outside of the design of the product, but it's still a big industry in and of itself. And for many organizations, it's a big expense, but it doesn't have to be. Customer service, when somebody has a problem with the product, that's often a first point of contact, is that customer service team. Well, how do we get that to be top notch and effective at actually helping solve problems and then preventing future problems? That's reliability engineering. So the series of questions is, well, what do you want to learn within the reliability field? And then pursue whether it's courses or mentors or books and so on, is then dependent on that particular area. Now, in general, just getting started is understand some of the basic tools. You need to know the difference between ALT and HALT. For example, some of the basic language we have. And so the CRE body of knowledge and the SMRP's body of knowledge are two great places to pick up the language and the different definitions and terms and concepts that are germane to reliability engineering. So that'd be a good spot to go with it. Let's see, Larry George, yeah, you're right. Survival analysis, and especially organizations that spend more time on medical devices or medical field. They don't call it reliability analysis or anything else. It's The other thing I learned, Larry, with the medical folks is they don't like infant mortality, especially when they're doing neonatal care for their product. They call it early failures, but the survival analysis overlaps tremendously with, and I think almost synonymously with, a lot of the reliability analysis type stuff we do, reliability statistics type stuff. Let's see. Williams, should a new graduate engineers become reliability engineers immediately at graduation, or should a solid engineering background be a starting place? Sometimes we just don't have a lot of control over that. And I know some people come out and they get assigned to their new job and says, oh, by the way, you're the new reliability engineer. You're the new one in the building. Whereas others are starting in mechanical engineering. I started in manufacturing engineering. And the types of problems I was drawn to led to getting more and more assignments in reliability related stuff, and eventually a pretty fun and exciting test for accelerated testing, and that got me hooked in that area. And I've heard that from a good number of people. The ones that are very proactive, knowing they want to get into reliability right from school, go through and get their advanced degrees, and they get their assignments and go off and use that. Whereas I would informally, and this is very non-scientific surveys that I've done over the years, is a good number of us are either drawn to the field and like the types of questions and problems that reliability engineering tends to focus on, or we get assigned. Our engineering directors is, hey, Fred, you're now the reliability engineer, go work on this project, or run this test, or explore this question. And so I think it works either way. I think what catches and makes reliability engineers very successful is a combination of an interest in that field, in the types of questions, how long will this last, how will it fail, understanding failure mechanisms and how they interact with the environment to occur or not occur, is different than a mechanical engineer saying, well, what's the loads? How do I distribute this weight? How do I create a structure that can withstand these different environments, and so on, and so on with the other fields of engineering. Different people are drawn to different aspects of the engineering in general, writ large. And so you could be assigned right out of school as an electrical engineer to become focused on reliability topics. And if it clicks for you, you'll probably stay in it and keep pursuing topics and projects in that area. If it's not something you're interested in, you'll probably go find jobs more on designing circuitry or setting up experimental systems or measurement systems or whatever, and get involved with something else. I don't think there's one way or another that's right. It's a matching of the person's interests, their talents, their passion, basically, and what the organization needs and what they're looking for. Now, what really clicks is when you are interested in the particular topic and make compelling proposals that say, if we focus on this aspect of reliability, it will save us a lot of money and make our customers happier. Making those kinds of connections really propels a career in the field. And so I think it's learning enough basics to see where the opportunities are, and then learning enough about finance or material science or engineering management to influence the organization to make those ideas and suggestions reality. Then it becomes exceedingly fun and very rewarding. There's lots of ways to go about doing it. Let's see what else here. I don't know. Well, I'm not sure if I answered your question, because it's kind of like follow your passion, but I think it's more complicated than that. I also don't, I think it can go either way. You can get really good at reliability engineering from graduate school, and not be very well versed in mechanics or material science or all the other things that we have to interact with, and then not be effective. I've seen that. And then the opposite is you could be a really good mechanical engineer and become an excellent reliability engineer also, have a real solid background, and you can talk to your team, the mechanical engineers in particular. I don't think anybody knows how to talk to software engineers except software engineers, but that's just me. But the idea is that I think both work, and it's more up to the individual and how they pursue that career than it is what path they took. Let's see, Williams also mentioned, it seems that program risk is becoming a reliability discipline. Suggestions for learning this area. Risk and risk management at the program level or at the enterprise level is gaining more and more press. It's becoming more prevalent in ISO standards and more business level discussions. It's not new. It's been around for a long, long time, but I think it's being identified now as risk management, where it was just business management before. Now, some of the basic tools for risk management are stuff that we do on a regular basis, hazard analysis, FMEAs, what if analysis, root cause analysis, all these different things that we do to identify safety issues or problems with the product's performance and so on. One of the biggest risks that our CEO at the time when I was at HP identified was the inability of the particular divisions with their product lines to accurately forecast their quarterly profits. And so we dug into that a little bit and to find out what was the leading cause of missing your numbers, either positively or negatively. And it was warranty. If you make a product that's better than you expected and the warranty money is being accrued at a higher rate than it's being used, you have resources tied up that you could have spent otherwise. And that's not good. And you miss your expectations for profitability that month, that quarter. Vice versa, if you make a product that's much worse than you expected, now you're spending money right out of profit. And again, you miss your numbers. And it was out of the 35 divisions that we had good numbers on, warranty was number one in all of them except maybe two, and that they actually hit their warranty numbers pretty accurately, but they had other problems. They missed their sales forecasts, kind of thing. But it's an area of risk that it isn't associated with reliability very often, yet it is a very real and very major business risk in the consumer product industry anyway. So part of risk management is understanding how the larger part of your organization talks about it and uses it, and then where do we fit in the engineering fields, and being able to communicate in the relevant terms and scopes and magnitudes of the issues that are being discussed. We're pretty well positioned as reliability engineers to do risk management. And where do we learn about that? Well, one of them is there's an article series that Greg Hutchins on Accendo moderates or edits, I should say. He has a number of different guest authors that contribute articles on it, and they talk about it quite a bit. And each of them have different references and books and so on. So I would pursue it's CERM, C-E-R-M, is the article series, and it's edited by Greg Hutchins, and he writes some articles in it too. He's got a handful of books available, plus many of his regular authors have references and books on it. And I know I'm drawing a complete blank. Well, I think it's John Ayers is a program risk manager or risk consultant. And program management is his field of study. So if you look for John Ayers articles, that might be a real good starting point to pick up, some ideas and concepts that you could then pursue with other avenues. So that'd be one idea. Yeah. Yeah, thanks, William. Yeah, I, you know, I guess I grew up in a factory and we didn't even have PLCs, the programmable logic circuits in our system. So there wasn't a whole lot of software. But yeah, I should learn more about software and software engineering to be effective in that, because it's such a vital part of so many systems we have. And so I really do need to get better at that. Well, that's something for me to learn. I'll add that to my task. Right now, I'm spending most of my time learning about website design and search engine optimization and all those kinds of things, and keeping the website running, which I guess is a reliability topic. But I think we're at a time. Thanks so much for attending and all the comments and questions. Appreciate that. Next, let's see, 2 weeks from now, Chris Jackson is going to have a presentation. I believe it's on the basics of HALT, H-A-L-T. He did one on ALT last month, and it was very, very popular. Then he got a whole bunch of questions about HALT, so he thought that might be a good next topic. My next topic is how to create a reliability plan, and that's based on the book that Carl and I are imminently or very soon, I should say, going to publish. Hopefully the last rounds of editing turn out well and quick and easy, and then we'll get that pushed out. So the presentation next month by me will be an hour synopsis of the steps we outline in the book of how to create an effective reliability plan. So with all that, have a great rest of your Tuesday, and we'll see you in a couple of weeks, if not next month or anytime in between. Please do send over questions and comments, and a lot of those end up being webinars and or especially podcasts. So thanks you all. Have a great rest of your day, and we'll go learn something, I guess is the final thing we should say.